Behind the ordinary objects that surround us in our everyday lives lies something extraordinary. Incredible stories of ingenious solutions to problems most of us never knew existed. So what mysteries are concealed in everyday things we take for granted? Diamond mines, skyscrapers, car crushers. Behind the ordinary is the extraordinary. Now revealed as we go behind the scenes, inside the machines, to find out, how do they do it? The Arctic Circle. You've got to be a bit strange to want to come here for a visit. You've got to be crazy to want to live here. Yet this is one of the most northern outposts of human civilization. In this blasted corner of northern Canada, temperatures sink beyond -45 Celsius. It's simply one of the least hospitable places on Earth. So why have people come here? On this forbidding Arctic island sits a volcano. In the floor of the volcano, vast quantities of diamonds are buried. This is the Diavik diamond mine. So how do you get a diamond from beneath a frozen volcano? How do they do it? It all starts with a bang. Every week, 500,000 tons of rock are blasted out of this crater. And from all that rock, every week comes just enough diamonds to fill a miner's hat. Once the scene of violent eruptions, the volcano has gradually been transformed into one of the world's richest deposits of a girl's best friend. They call the veins of volcanic rock the kimberlite pipes. The trucks crawl cautiously up icy tracks which have been gouged out of the side of the crater to deliver their precious loads to the processing plant. It may look like a pile of rock, but in every journey out of the crater, each truck is carrying an average $70,000 worth of diamonds. The majority of the world's diamonds are destined for industrial use, but most of the precious stones from Diavik's volcano end up gracing the neck or fingers of some lucky woman. To get at these gems, thousands of tons of volcanic ore must be crushed and reduced to bite-sized chunks less than 25 millimeters across. The problem is, how do you break the rock down into small chunks without damaging the diamonds inside? In Diavik's vast diamond plant, the volcanic rock passes through a series of crushing machines. These monster crushers are fine-tuned so that they act on the softer rock, leaving the diamond-rich rock intact. In the control room, an operator watches out for problems as the rough diamonds are separated from the rock.
A diamond is very hard, so this machinery is equipped to spike out at a hard piece and recognize a diamond without crushing it.
The chunks of ore are gradually reduced in size and the diamond-rich rocks are filtered out and sent to machines called sizers. The sizers are huge barrels which spin the rocks. As the fragments bounce into each other, they break up even further and fall through a series of smaller filters. Then the rocks are washed with water and a corrosive substance known as magnetic oil sand, which consists of bitumen, sand and clay. The wet rocks bounce into a machine that acts on them like a cyclone until finally they emerge looking like this. These are precious stones which are still attached to tiny chunks of worthless rock. Now these thousands of small stones are transported under armed guard 300 kilometers south to one of the most heavily fortified complexes in North America. Here, there's a more refined production process. To finally separate diamond from stone, you need to heat the rocks and then treat them with an acid so corrosive, you really need a robot to do the job safely. After their acid bath, the diamonds emerge from the rocks. Now they can be weighed and sent to be cut and polished. To transform a rough diamond into a glistening jewel, each one has to be examined by the factory foreman. He's effectively the architect of the diamond, carefully analyzing each stone, looking for flaws and features. He decides how to cut the stone to create the most elegant, symmetrical shape while discarding the least amount of diamond. He's helped by a computer that looks right through the stone. Once the best cut is marked, it's sent for cutting. The problem now is, how do you cut the hardest mineral known to man? Well, it takes a diamond to cut a diamond. A diamond-tipped steel wheel spinning at 12,000 revolutions per minute is used to cut through the rock, slowly and carefully. A single cut can take 12 hours to complete. Once cut, the diamonds are sent to the bruting room to be rounded. This is achieved by grinding two diamonds against each other. Once the grinding machines have done their job, the facets are added to each gem. These facets are the flat surfaces on each stone. They're produced by polishing the diamond against a diamond-coated steel disc. Once completed, the diamonds need to be brillianteered. This is when they're polished to sparkle like the stars in the night sky. This is achieved by using a machine called a skate. It's held against a cast iron disc coated with diamond powder and running at 35 RPM. After its polish, the diamond goes off for a final quality control check.
I like the idea that someone out there is wearing my stone. I like the idea of other people wearing it.
Next stop, a high-class jewelry store where the rocks will be admired by women and burn holes in the pockets of men. Welcome to Taipei, Taiwan. Here you can visit the ancient temples. You can observe the morning rituals which are carried out today just as they have been for centuries. But now you can also marvel at the tallest building in the world. The design is a strange mix of ancient and modern. This extraordinary building is a staggering 125 meters taller than the Empire State Building. It's the first skyscraper to surpass 500 meters. Taipei 101. But there's a problem with Asia's building boom. The region's typhoons and earthquake faults pose extreme threats to tall buildings. So, how can they build ever taller and still counteract these awesome forces of nature? How do they do it? It was here, in Toronto, Canada, that they cracked the problem. Toronto boasts the world's tallest freestanding structure, the 553-meter-high CN Tower. It's also the headquarters of skyscraper experts, Motioneering and RWDI. These guys are world leaders in designing tall buildings, and they immediately realized putting up the world's tallest skyscraper in Taipei was going to be a big problem.
They set themselves a real challenge. I mean, they get their typhoons several times a summer. They had their work cut out for them.
The only way to find out if such a tall building could even hope to survive a typhoon was to test it in a wind tunnel. To do that, they had to make an intricately detailed scale model of the proposed tower. Even a small element of the design could present a potential risk, so everything had to be replicated. The next problem was how to monitor the stresses the building would exert on its foundations during high winds.
A building actually bends, it sways backwards and forwards in the direction of the wind and also in the crosswind direction. So it's actually doing this.
Thousands of sensors are attached to the model to measure the stresses on the tower's foundations. The smoke allows the engineers to observe the wind turbulence caused by the tower. But testing the tower in isolation isn't enough. Surrounding buildings can themselves cause unusual airflows which might affect the tower. So every building around the proposed tower had to be recreated using polystyrene. Only this way could the wind patterns around the skyscraper be truly duplicated. The guys at Motioneering's workshop are past masters in the art of building miniature cityscapes. They've got models here for most of the world's major centers. But it's not just the tower they're concerned about. As the typhoon wind swirls around the skyscraper, it could potentially create havoc for pedestrians in the street below. So they test for that too. The data on Taipei 101 suggested that angular edges needed to be chamfered or blunted to look like a W in order to reduce wind drag. The foundations also needed to be strengthened. With these modifications, the sway of the tower in high wind was reduced significantly. But it wasn't enough. When you're 500 meters up, any movement can be alarming.
They have an entertainment area, sort of a restaurant and a bar up at these levels here. And in relatively common winds, like occurring twice a year, sort of a half-year return period, we call that, that the level of acceleration of those floors might get high enough that people would begin to notice it or become nauseous by it.
Something new, something radical was needed. The designers of Taipei 101 decided to build a vast counterweight inside the tower. An incredible 660-ton solid steel ball. And this is it. It's 6 meters wide, weighs more than 2 jumbo jets, and is suspended on 8 cables from the 92nd floor. It's called a tuned mass damper, but effectively, it's a gigantic counterweight. And it has to be huge, because Taipei 101 itself is huge. It works by turning the entire 500-meter tower into an upside-down pendulum. When the wind picks up and the tower starts to move in one direction, the 660-ton ball swings in the opposite direction, and the building stays almost motionless. The designers used computer models to test the theory. Even in typhoon-force winds, the damper successfully stabilized the tower. You might think that including such a hulking great metal ball would ruin the design of this beautiful building, but instead, the architect decided to make it the centerpiece of the building's 88th floor viewing gallery.
Now, the architect was really sort of forward-thinking about this one because this two-mass damper is not a little sort of dirty secret that they want to keep from everybody. They've installed it right in that area where everybody sits and eats, so they can see the two-mass damper moving.
In fact, they've turned the damper into a tourist attraction in its own right, painting it gold the colour of good fortune. But no one could be absolutely certain that it would work until a typhoon hit.
The ball was actually moving, but inside the building you don't really feel anything because the wind damper has proven to be very effective.
In Europe today, 80% of every old rejected car, its body, engine, wheels, upholstery, must by law be recycled. In fact, it's highly likely that the car you're driving right now is built from someone else's old banger. It's a piece of modern engineering magic, a kind of metal cannibalism. So, how do they do it? The Newport Docks in Wales. This is the end of the line for 100,000 cars every year. Soon our clapped-out wrecks will be smashed into 1,000 tiny pieces. Raw material for a new, younger, better kind of car. For in these docks lives a giant monster, the largest car shredder in the world. And it has a voracious appetite. This awesome machine can swallow up and spit out as many as 450 cars an hour. That's almost 8 cars a minute. It crushes, smashes, and hammers them into tiny pieces and spits them out again in a matter of minutes. But even for a monster like this, chewing up cars is a perilous business. The trouble is, every car arrives with a cocktail of explosive chemicals swilling about inside. Each one is like a bomb waiting to go off inside the masher's hungry jaws. So first, the bomb must be diffused. This is the bomb disposal squad. Before shredding this Green Rover car, they remove all the material that could explode when it's crushed. They bleed out all the liquids, the petrol, oil, antifreeze, coolant, brake and battery fluids. Now there are no poisons to leak into the earth and no liquids to ignite during the crushing process. For the Jolly Green Rover, it's time to meet its maker. The little car is dragged mercilessly through the gates of hell. First, the crusher flattens the hulk with enormous rollers. Then 20 massive half-ton rotating hammers, propelled by this red wheel, smash it to pieces. The crusher chews the chunks to digestible-sized frags, or shredded metal fragments. The machine is so powerful, and the process is so violent, it actually makes the ground shake. Now the recyclable metal has to be separated from the other jumbled materials. To sort the steel frags from the copper, brass, stainless steel and zinc, the pieces are exposed to powerful magnets. But the magnets can only do so much. For the final sifting and sorting, you need humans. In this picking and sorting shed, men work day and night, separating the metals which need further refining from the steel. Apart from the thousands of dollars worth of loose change found under the seats, steel is one of the most valuable products from these crushed used cars.
Oh, there's a piece of my Green Rover.
The massive crusher thunders on relentlessly, turning 100,000 cars a year into fist-sized fragments that will then be exported all over the world. The Jolly Green Rover will now form part of a cargo of valuable raw material that will be sold to car makers who will transform it into a new generation of motor car. This ship, the Golden Sky, is headed for China. It's only a matter of time before the Jolly Green Rover rides again. This time, he won't have a dodgy clutch. Hopefully, he won't be that revolting shade of green. But it's nice to imagine that his Jolly Rover soul will carry on. So just remember, the next time you climb into your brand new car, beneath the surface, it's an old green Rover with 200,000 kilometers on the clock. Behind the ordinary things that surround us in our daily lives are miraculous advances in engineering which we rarely get to see. Ingenious solutions to problems most of us never knew existed. Since this program began, $25,000 worth of diamonds have been found in Canada. 3,500 people have been working safely in Taipei 101, and 180 cars have been crushed in South Wales. Even the most ordinary objects have an extraordinary story to tell. We only have to watch and listen.
接下来，从老式蒸汽机到革命性的高科技火车，历史上10大最佳火车排行榜，超猛机械王接着播出。
Behind the ordinary objects that surround us in our everyday lives lies something extraordinary. Incredible stories of ingenious solutions to problems most of us never knew existed. So what mysteries are concealed in everyday things we take for granted? Air-to-air refueling, ski slopes, car production. Behind the ordinary is the extraordinary. Now revealed as we go behind the scenes, inside the machines, to find out, how do they do it? If you think your people carrier's a bit thirsty in the old gasoline department, you should try doing the school run in one of these. An F-15 fighter jet burns up to 4.5 litres of fuel every kilometre, and as they cover a mile in the blink of an eye, that's one gas-hungry bird. Worse still, to keep it light, the F-15 carries a maximum fuel load of 12,000 litres. So to make sure it stays in the air, it has to be refueled in the skies, which is one of the most dangerous aircraft operations there is. So how do they do it? At Mildenhall Air Force Base in the UK, American pilots train every day, practicing this perilous flying maneuver. Air-to-air refueling. To do this, you need some pretty special planes. And this is where the KC-135 Stratotanker comes in. You also need a crack team of specialized pilots. And they don't come more expert than these guys. The 100th Air Refueling Wing, which is dedicated to this single highly dangerous task. Today, we're going to follow the 100th on one of its missions. This is Matt, and he's the commander.
Since I was a young child, I'd always looked up at the skies and seen aircraft flying around and always wanted to be one of those guys, one of the pilots that were in the aircraft. So I'm lucky to have this job, and yes, I do. I love it.
The KC-135 is carrying close to twice its own weight in fuel. That's over 125,000 litres, enough to keep a normal car running for almost 50 years. But carrying that much fuel is itself highly dangerous. Much of it is stored in 6 huge fuel tanks spread through the main body of the plane, but a large quantity is also stored in the plane's wings. They carry fuel in the wings for one remarkable and worrying reason. If they didn't, the wings would snap off.
The design for the fuel to be in the wings is physics. What happens with wings is they fly up. And if all the fuel were in the middle of the airplane and all the weight were in the middle of the airplane, your wings would actually fly up so high that they would separate from the airplane. And so with the fuel in the wings, it keeps the wings down as they create the lift.
The KC-135 is the workhorse of the Air Force. Sturdy and reliable, it's been in service for 50 years, and there are still more than 500 of them in use around the world. But air-to-air refueling is so dangerous, there's no room for error, so the safety checks are doubly important.
You really have to check to make sure everything looks good, because the wings are really heavy right now. Our jet's under a lot of stress with so much fuel. So, everything looks good today.
The checks complete, their mission begins. The F-15s which need to refuel are already over the Atlantic. They've just a few hours of fuel left, but the KC-135 is on its way. Before rendezvousing with the fighters, it has another mission. A Hercules transport plane also needs refueling. Using GPS, the crews arrange a time and space to meet up. But once they're within a few miles of each other, the system becomes less technical. They look for each other out of the window. The boom operator, John, is in a tiny compartment on the underside of the stratotanker. From here, he can see the incoming plane, which is known as the receiver.
And right now, we're just waiting for the receivers to come up.
The boom operator has sighted the plane, and it now moves closer to the refueling aircraft.
After 20 years of doing this, I just hope that the receivers are very stable and we can get the gas offloaded real quick.
The receiver has to fly behind and below the KC-135. It's a risky operation, as the receiving plane could easily get caught up in violent turbulence from the massive stratotanker. With both planes flying at over 300 kilometers per hour, the boom operator has to bring them within just 12 meters of each other.
This is the fun part of the job.
As the Hercules comes closer, the boom operator uses signals to guide it into the right position.
Right about there's 20 feet.
But there's still a huge problem, actually transferring the fuel from one plane to the other. On the underside of the KC-135 is an extendable boom. It's the key to air-to-air refueling. And the secret to guiding the boom into position are the 2 wings mounted either side of it, which can be remotely controlled by the boom operator.
I can fly the boom from side to side, up and down, wherever it go, wherever I turn my hand, the boom follows.
With the Hercules now in position, the boom operator first extends the boom by a further 3 meters, then, cautiously, a further meter. He's getting nearer the target, but it's only the size of a paperback book, and the 2 planes are both traveling faster than Formula One racing cars going flat out. This is the moment of truth. The boom operator must focus all his attention on making contact with the other aircraft. Bullseye. When the boom locks, it completes an electrical circuit between the 2 planes. Now the pilots take over. The stratotanker can transfer a staggering 4,000 liters every minute, but moving that much fuel that fast is a massive threat to the stability of the plane.
This is what we call a fuel panel, and in each number stands for the amount of fuel that's in that tank. So what we do is we look at the tanks and we say, okay, let's take a little out of this tank and give it to him, and we can actually stop the refueling and go to another tank while he's in contact. So it makes things a little easier. However, we have to watch the center of gravity while we're doing that to make sure that we don't give too much fuel from the rear of our plane, or our plane does this. If we give too much in the front, then our plane does this. So you're constantly monitoring everything.
These planes transfer fuel at a phenomenal rate. In 24 hours, an ordinary petrol pump still wouldn't transfer as much fuel as this plane does in just 8 minutes. Once they've refueled the Hercules, it's time to disconnect.
Offload complete. Disconnected.
And with its tank now full again, the Hercules is ready to continue on its journey. But for the KC-135, it's time to meet up with the F-15s. These fighters can't safely fly slower than 530 kilometers per hour, so the KC-135 has to accelerate to keep up with them. But once the F-15 has locked on, transferring 1,000 liters of fuel is done in a matter of seconds. For today, our cruise mission is accomplished. In the time you've been watching this, a Stratotanker will have transferred enough petrol to keep your car running for 8 years. The snow-capped Rockies, a vast expanse of pristine wilderness, natural and unspoiled. Or is it? Thousands of people hit the Canadian Rockies every winter to ski and snowboard and generally have a rollicking good time. This is Lake Louise. It's been voted North America's most beautiful ski resort, and it's the largest in Canada. It boasts over 100 runs spread across more than 16 square kilometers of mountainous terrain. Every hour, these lifts can carry almost 20,000 skiers into the mountains.
Skiing is a great sport. It's whatever you want it to be. You can ski with your friends, you can ski with your family, powder ski, groom ski, ski with music, sunny days, cloudy days.
Ski tourism is a multi-million-dollar industry, but it relies on one very unreliable thing: snow. The average snowfall here is 4 meters a year, but averages don't help much. When the snow doesn't fall, everything stops. So what do they do when they run out of snow? To guarantee satisfaction throughout the ski season, the folks at Lake Louise have a secret weapon. And this is where it's hidden: snowmaking control. Inside this innocent-looking shed sit 4 huge pumps capable of pushing out more than 4 million liters of water a day. Alongside the pumps are 2 massive air compressors. Together, the pumps and compressors provide the key ingredients to making snow. But where does all this water and air go? It's pumped to over 90 towers, just like this one. This metal arm reaches up 30 feet into the air. At the top, the water and compressed air meet, and a nozzle distributes a fine spray onto the slopes. So long as the air temperature is close to 0, the water freezes into ice crystals and gently falls onto the slopes as snow. Alongside the big guns at the top of the towers, Lake Louise also has a battery of smaller weapons, including more than a dozen of these fan guns. Together, the towers and fan guns can cover 15 acres with a 2-foot deep blanket of snow in a day. The problem now is that the newly formed snow has landed unevenly and must be distributed. So, how do you turn a snow heap into a ski run? When the pistes close and dusk descends over the resort, a pack of nocturnal beasts emerges onto the slopes. The snowcats. With their massive 350 horsepower engines, the agile snowcats purr along, driving the excess snow uphill. They can climb 45-degree slopes without breaking into a sweat. At the back of the snowcat is a tiller which combs the piste into fine lines known as corduroy. This will allow the skiers to get a better grip on the virgin terrain.
The biggest challenge is making the pass look beautiful. Like that's what we're here to do. We're here to, you know, offer corduroy to the 3-year-old who is on his or her first pair of skis or snowboard for the first time ever, and then for the 65-year-old who's just out enjoying retirement. You know, we just want to make everything perfect.
A car means freedom, so no wonder everyone wants one. There are more than 550 million cars in the world today, and we're making 45 million new ones each year. As the world grows more prosperous, the demand for cars is increasing, and car plants are getting more amazing all the time. So how do they churn out cars at high speed in one of the world's most advanced plants? How do they do it? Tanjung Malim is 70 kilometers north of Kuala Lumpur. This valley used to be an impenetrable jungle. Now it's proud, gleaming Proton City, which will soon be home to over 2,000 car workers. There's Proton City School, Proton City Sports Stadium, Proton City University Campus, and Proton City Mosque. They started building Proton City in 1996, and it's making more and more cars all the time. Right now, they're churning out 150,000 a year. The Proton City factory is one super long production line covering 5 million square meters. That's like 700 St. Paul's cathedrals. Everything needed to make a modern car is under one roof. The first ingredient for a car is this massive ring of sheet metal.
Every day we run about 20 coils to do production.
Each one of these huge coils makes 20 cars. The steel rolls spool into the 4,600-ton stamping machine. Here it's cutting the outline of the car doors. One every 2 seconds. And making it look as easy as cutting pastry shapes. The doors then pass into the press. This is one of the largest metal presses in Southeast Asia. Meanwhile, 1 kilometer down the line, it's time for a small army of robots to get to work welding the chassis. These robots are the latest thing in manufacturing artificial intelligence, and they perform their task with incredible speed, dexterity, and accuracy. And in this plant, there are 180 of them, making 350 cars a day. It takes these robo-whiz kids just 20 minutes to assemble this chassis. The line only pauses for up to 8 seconds at each robot station before moving on. The next step is to protect the car from rusting with a dip in a bath of zinc phosphate. Then the car is painted by some slightly more artistic robots. Needless to say, they do it perfectly every time. And just in case the tiniest particle of dust casts a blemish on the perfect paint job, 1,000 beady robot eyes inspect every car from every angle before it is moved by some unseen mechanical hand to the next stage in the process. But just as you thought the metal Mickeys could handle the whole deal themselves, here are some humans for light relief. Even in the most advanced modern car plant, skilled engineers are still needed for tasks requiring complex hand-eye coordination. So when do you need a man? For an impartial opinion, let's ask a woman.
The robot is good when it involves a heavy part. Men are good when we have to work in a team.
Finally, humans and robots come together to give every car a rigorous quality control check. More than 2,000 components are tested. One last test of the brakes, and this car is ready to leave Proton City to join the 550 million others that keep us on the move. Behind the ordinary things that surround us in our daily lives are miraculous advances in engineering, which we rarely get to see. Ingenious solutions to problems most of us never knew existed. Since this program began, a refueling plane has transferred enough fuel to keep a family car running for 30 years. 10,000 people have been skiing on man-made snow, and 2,500 cars have been built around the world. Even the most ordinary objects have an extraordinary story to tell. We only have to watch and listen.
接下来，从太空船到下水道，从天空到海底，为您揭晓10大最佳运输工具排行榜。超萌机器网接着播出。